Hi, this is Wendy Lightheart, and today we're going to learn how to solve quadratic equations by factoring. So first let's look at the definition of what is a quadratic equation. A quadratic equation in X is an equation that can be written in the standard form ax squared plus bx plus c equals 0. Where a, b, and c are real numbers with a not equal to 0. A quadratic equation in X is also called a second degree equation in X. So in order to solve equations by factoring, we need to understand an important principle called the zero product principle. If the product of two algebraic expressions is 0, then at least one of the factors must be equal to 0. So in other words, if a times b equals 0, where both a and b represent some algebraic expression, then a equals 0 or b equals 0. So let's use that zero product principle to solve this equation, which has already been factored for us on one side. So this equation is saying that the product of x plus 5 times 2x minus 1 is equal to 0. So by the zero product principle, the only way this product can be 0 is if at least one of the factors is equal to 0. Thus, x plus 5 equals 0, or 2x minus 1 equals 0. So we just need to figure out what values of x will make either of these factors equal to 0, and those will be our solutions to the original equation. So to find those x values, we just need to solve each of these equations to find these solutions to the original equation. So let's solve these two equations. To solve the x plus 5 equals 0, we can subtract 5 from both sides to obtain a solution of x equals negative 5. And of course you might have been able to see what value of x would make that equal to 0 without actually doing the solving step, and that's okay too. For the next equation, to solve it, we'd have to add 1 to both sides, which would give us 2x equals 1. And then to finally get the x by itself, we'd have to divide both sides by 2, which will give us another solution of x equals 1/2. Thus, if x equals negative 5, then this equation will be true because the factor x plus 5 would be equal to 0. And if we multiply anything times 0, we get 0. Similarly, if x equals 1/2, that will make the equation 2x minus 1 equals 0 true. And so you would have x plus 5 times 0, and anything times 0 is 0. So both of these are solutions to the original equation. So our solution set includes the number negative 5 and the number 1/2. So let's go over the steps of how to solve an equation by factoring. So first of all, if necessary, rewrite the equation in standard form, which remember is ax squared plus bx plus c equals 0. In other words, you want to move all the terms to one side, which leaves a 0 on the other side. And then you also want to make sure the terms are ordered with the x squared term first, and then the x term in the middle, and then the constant term last, so that it's all ready to be factored, which is our second step. So once you get it into standard form, factor the expression that you end up on the other side of the equal sign to 0. And after you factor that expression, then you're going to apply the zero product principle, which says that the only way that product of factors would be equal to 0 is if each of the factors equals 0. So we're going to set each of those factors equal to 0 to find those solutions. And after we set them equal to 0, Then we have new equations to solve, and so our fourth step is to solve those equations we obtained in step 3. And then, as always, we can check our answers. So we would take our solutions one at a time and substitute them back into the original equation and see if they give us a true statement. So let's look at a couple examples. So for this example, we have the equation x squared minus 7x equals 8, and we've been asked to solve this by factoring. So our first step, remember, is to rewrite the equation in standard form. So we're going to need to move all the terms to one side, and that will leave a 0 on the other side. So what we can do is subtract 8 from both sides, and that will get all the terms to the left side and will leave us a 0 on the right side. Now I could have moved all the terms to the right side, but that would have given me a negative x squared term. And if possible, it's easier to factor if you have a positive coefficient on your x squared. So that should be one of your goals, is to move all the terms to whichever side will leave that x squared term positive. So now we're done with step 1, and step 2 is then to factor. So we need to factor this equation, or the left side of the equation rather. And so this is a trinomial whose leading coefficient is 1. So we're looking for two numbers that multiply to give us negative 8, which is our constant, and add to give us our middle coefficient, which is negative 7. So you may have already thought of the numbers that would work, which would be negative 8 and positive 1. So we plug those in the parentheses with the x's to get our factors of x minus 8 and x plus 1. So if those two factors multiplied together give us 0, the zero product principle says the only way that that can happen is if either of those factors equals 0. So that brings us to our third step, which is to set each factor equal to 0, and then our fourth step is to then solve these equations. These two equations are fairly easy to solve mentally, so you probably can already tell that x equals 8 would make the first equation true, because 8 minus 8 is 0, and x equals negative 1 would make the second equation true, since negative 1 plus 1 equals 0. So those are our two solutions to that original equation. So now let's check the solutions to this equation. So we're going to take the original equation, which you see up above on top, and replace all the x's with 8 first to check that solution. So we have 8 squared minus 7 times 8, and we're checking to see if that is equal to 8, because then that would make that a true statement. So we simplify the left side, which will give us 64 minus 56. Is 64 minus 56 equal to 8? Yes, it is. So we end up with a true statement for the proposed solution of x equals 8, so we know that that is a true solution. Let's check our other solution of negative 1. So we do the same thing. We take our negative 1 and replace all the x's with that number. Now it's important that you're squaring negative 1, the whole thing, so you want to put that number inside parentheses. So when you square negative 1, you get positive 1, and then negative 7 times negative 1 is positive 7. So the left side simplifies to 1 plus 7, and is that equal to 8? It sure is, so we also get a true statement when we check the proposed solution of x equals negative 1. So both of those solutions are true solutions. So next let's look at an application problem. This is a common application problem that you'll see when you're solving quadratic equations. So this says that if you toss a ball upward with an initial velocity of 32 feet per second from a height of 48 feet, then the equation h equals negative 16t squared plus 32t plus 48 models the height, which is h, that the ball will be above the ground after t seconds. And this is asking you to find when will the ball hit the ground. Well, how high above the ground will the ball be when it hits the ground? Well, it won't be any distance above the ground, which means that the height at that time will be 0. So really what it's asking is, at what time t will h be equal to 0? So your first step is to replace the h with 0. Now notice that this equation is already in the standard form in the sense that we have 0 on one side and all the other terms on the other side. But notice that we have a negative coefficient on the t squared term. So I'm going to show you two different ways to approach this, because this is a very common form of a motion problem quadratic equation where you will have a negative 16 as your coefficient. So first we're going to show you how to factor out a negative GCF and deal with it that way, and then I'll show you another way. So if you have a negative coefficient on your x squared or your t squared term in the front, then it's best to factor out that negative with the greatest common factor. So the greatest common factor between 16, 32, and 48 is 16, but we're going to pull out a negative 16 so that the remaining factor has a positive coefficient on the t squared so that it's easier to factor. So now we need to factor that t squared minus 2t minus 3. So we're looking for two numbers that multiply to give us negative 3 and add to give us negative 2. So you probably guessed that the two numbers that work would be negative 3 and positive 1. So now we have our equation factored completely on the right side. So once we have it factored, then we apply the zero product principle. So the only way that this product will equal 0 is if at least one of these factors equals 0. Well, negative 16, which is the GCF, it is a factor, but there's no value of t that would ever make that equal to 0. So we don't have to worry about setting that equal to 0. So instead we take the other two factors, the t minus 3, set that equal to 0, and then take the factor of t plus 1 and set that equal to 0 as well. If we solve these two equations, we're going to have solutions of positive 3 and negative 1. So then we need to answer the question. So how long does it take the ball to hit the ground? Well, the ball hits the ground after 3 seconds. And that's because the t equals negative 1 doesn't make any sense, that the ball would hit the ground 1 second before it's even thrown. So we discard the negative solutions when they don't make sense in terms of the problem. So for this one, even though there's two solutions to the equation, there's only one that actually solves the application problem. So now let's look at the same problem but using a different approach to solve the equation. So here's the other approach. So first remember we replace the h with 0 because we know that when it hits the ground the height is 0. But instead of factoring out a negative GCF, what you could do is to move all the terms to the other side. Because when you move all the terms to the other side, all of those terms are going to change signs. So that's going to make the t squared term positive. So now we have it in the correct form, but we have a negative or a positive coefficient on the first term instead of a negative coefficient like we had before. So now we factor out that GCF of 16, and notice we get the same remaining polynomial as before. So we factor that, and we get the same solutions. So that's it for today. Have fun solving these quadratic equations.